Okay, hello everybody. This is Mike here again. So this is my continued series of programming videos, intro to programming videos for kids using the MicroBit um, by BBC and MakeCode by Microsoft. So in the last video, I kind of showed you how to use their radio commands or basically using Bluetooth with the MicroBit. MicroBit's built into, I'm not sorry, Bluetooth is built into the MicroBit. So in the last example, I had two microbits, and I basically sent signal back and forth between the two microbits. So in this example, I'm going to use 3 microbits. You can use more than 3. You can basically use 2 to 255. So you can have up to, I guess, up to 255 microbits on the same basically Bluetooth network. At least that's the max number you can use. So once again, this is a little more complicated because I'm, like I said, I'm using 3 microbits. So again, let's share my screen and show you the code. So like I said, I'm using MakeCode by Microsoft, the microbit. And let's do this group. I'm using the pirate skull again. And this example, you really don't need this example or simulated microbit right now. So you can see all 3 code examples. So like I said, this is a little bit more complicated. It looks a lot more complicated than it actually is. So let's kind of break it down real fast. You're going to need, let's make it simple. Let's go to variables. So you're going to need 4 variables. This will make more sense as we go along. The hash skull variable, you can name these different names, but the hash skull variable is basically a true and false variable. I'll show you how to set that up here. The ID, that is the ID of the microbit. Players, that's how many people, how many robots. That probably should be robots. You can actually rename these and it'll update. So basically you have 3 robots. And you basically have this true and false, another true and false. Oh, actually said that's a number. Sorry. Haskell's true and false. ID is a number. Robots is a number. And Sin2 is a number. I'll show you how to do this more. So you need 4 variables. Pretty simple. When you do make a variable, you just name it and it creates it for you. Okay. You're going to need an on start. So when the microbit starts up, this code's run. You need, for my example, I'm using on button press. So you need on button, and that comes from the input on button right here. On start, you can grab one here from the basic. And then we got the special one, the radio commands is on radio receive. So this is basically on receiving a Bluetooth signal. And that's under radio. So now There's on ready to receive, receive a string. On ready to receive, receive a number. So I chose the on ready to receive, receive number. We're receiving a number for this one. Okay, those are your three basic loop structures. Actually, it's almost like three different methods that you create. So let's start with the on start, because this will start making more sense once you see something, once I start coding for you, showing you. So the on start. So the first command is this radio set group. And you grab it out for the radio menu, radio set group. What that does, this is the 1 through 255. I think it's 255 for, yeah, 255. So that number is basically, you can make this any number you want from between 1 and 255. And that number will be your communication, your handshake number, your unique identifier for your robot group. It's a unique identifier for your robot group. The next one is this radio command. So you're basically setting robots. Where is that? Set robots 2, 3. Oops. Why did I just lose it? Oh. See, it's here in the variables. Sorry. So what you do is you grab this set, and then you grab the robot. You just click down to get the robots. Remember, the robots is how many robots in your group. Or not how many robots in your group. It's you're setting each robot, you give it a unique number in the group. So the set group gives overall group. So the 42 means that 42 is basically the group name for the group you're creating, your network. It's your network name. And then each individual robot will get a number between 1 and 255. And each robot should get a unique number so you can communicate back and forth. So in this instance, no, I didn't explain that right. So what we're saying is there is 3 robots in the group. So you can have 1 through 255, the number of robots. Group is the group unique identifier, setting robots to how many robots in the group, and then the ID is the number of the robot within the group. Yeah, I think I explained it right that time. So let's do that one more time. So I think I messed it up. The group is the unique identifier for the group of robots. So in my group of 3 robots, I'm setting the identifier group number to 42. It can be any number between 1 and 25. Then I'm setting how many robots are in the group. That's 3. 1 through, you can have 1 through 255, but I'm saying 3. The ID of each individual robot is then also set. And in this instance, I'm setting to 2, but whenever you upload the code, this is very important. Whenever you upload the code to a robot, you need to give it a unique number identifier. And so when I'm working with robot 1, I set that to 1. When I'm working with robot 2, I set it to 2. When I'm working with robot 3, I set it to 3. These are kind of like, in a sense, these are kind of like global variables. You set these variables up and they use them throughout your code. Then this next one is just a basic command. I'm showing the ID of the robot on the little LED matrix. And then we have an if statement. Basically what the if statement is saying, if the ID of the robot is equal to 1, which means it's the number 1 robot, then set Haskell to true. So as you can see in these first 3 variables, this is not the kind of unique thing about this blocks code. So as you see here, when you set up these variables, you're assigning them a number. So they become a variable that is a number-based variable. So this radio, when you set the radio group, set the robot, set the ID, you're basically setting them up to be numbers. And so when you try to evaluate the ID, you need to evaluate it as a number. It is storing a number. The set skulls is basically now a Boolean, a true and false variable. You can only assign true or false to it because you said set. When you do the set command, you then identify what kind of variable it is, a true or false variable or a number variable. So when I set this Haskell to true, Haskell will no longer be either true or false. And so basically what this is saying is if the ID number of the robot is 1, then at the beginning of the game, Haskell is 2, which means it'll just display the skull symbol and it'll basically be the starting robot. Else, if it's not 1, if it's 2 or 3, then it doesn't have the skull. So it'll be set to false. Basically, just whichever robot has control of the skull at that one time, the robot that can send the skull. We can test that. When I show you the robots, we can test that. Make sure that's working. Make sure I got that set up right. Okay. So now we're going to use these variables we set up to send by the radio commands, menus, basically the Bluetooth, information back and forth between the robots. And so we would press A, so there's like we've seen in the past, there's 2 buttons on the front of the MicroBit, and on the press of A, this is what's going to happen. Select method call on a press of A. So if Haskell, so this is basically saying if Haskell is true, then set, so we do another set command, and this is telling the sent to is a number also because we're assigning in a number. So of the 4 variables, we now set up what all 4 variables are and what they do in the program. So we set the send to variable to pick a random number. So we're picking a random number, which is from 1 to robots. So this is important because we don't want to pick a number so we have 3 robots. We don't want to pick a number of 4 robots or 5 robots or 6 robots or 7 robots. We only want to pick a random number between 1 and 3 because robots is assigned. Remember, it's assigned over here, set robots to 3. This is the number of robots in our network. So this is where this robots comes in handy. We can add robots or subtract robots from our network, and when we download the code and so on. So we can easily add more and more robots up to 255. So next step is if that send to that the random number we picked up here, if that is not equal to the ID, which is the ID of the robot that we assigned to it, and in this case, it's 3, but it can be any number from 1 to 3 because we have 3 robots. If it's not equal to the ID, which means you're going to send it to another robot, Then set Haskell to false. So basically we're saying is the robot no longer has control of the skull or the who can send it. It can't send it. It won't be able to send it from now on. And show number again. So basically we can always keep track of what number each robot is. And then it will do another. So that set is another variable. Remember the ifs come from the loops. Sorry, the logic. So all the ifs, all your if statements from there, your comparisons are from there. So that's where you get the ifs. And it's really easy to plop them down in there. Robots. You make that connection, send to ID. You plop the ID there. You can toggle this back and forth to true and false. We want to keep it false. You can easily drop the ID down on their show number. That's another show arrow, show number right here from basic. This radio, the radio send number, that's also one of those radio commands. So basically radio send number right here. And then we can click on the variable and the send to variable. Just drop it in there like that and then put it in there. We don't need that. I hope this is all making sense. So basically we nested this if right here, if into the if, inside of this if into the if. So we're only doing this if when the MicroBit has control of the skull. And if it has control of the skull, then it sends it to another robot. Now, sometimes there's a little bit of a flaw in my program. I must admit up front. So if it picks itself, you'll see that it'll pick itself. If it picks itself, it just won't do anything. And you'll just have to keep pressing A until it picks another robot. So if one picks one, nothing happens really. It doesn't send anything, doesn't do anything. This right here, this if statement basically doesn't happen. If one already has control of the skull and one picks one, nothing happens. If two picks two, nothing happens. If three picks three, nothing happens. Hope that makes sense. Then finally, we got the on radio received. On radio received. And we receive a number. Remember, you can see a string and a number. In this case, we're receiving a number. I'll make an example tutorial later on where we receive a string. But right now, we're just sending, receiving numbers. So so when you transmit, all the microbits are going to receive the signal, except maybe the one that transmitted. But at least the two that didn't transmit will receive the signal. So receive the Bluetooth signal. So on the received number, if the received number That's a good question. I'm trying to think of how to get that received number one, if received number. So if the received number, you can basically duplicate the received number, like on the radio. So basically on the received number, set ID equal to 1, not equal. If the received number is equal to your ID of the robot. So what we're saying here, when the microbit receives a number, if the number received is equal to the ID of the robot. So what we're saying here is when you assign the robot a number, let's say right now it's 3. If 3 receives 3, then basically the robot gets control of the skull and displays the skull. So you set the skull true or false, variable, Boolean, basic Boolean variable to true. That means that it has the skull now. It's the only robot in the network that has the skull, and then it displays the skull. And those sets are here. When you set up a variable, you get the option to be able to use the variable. And yeah, but we don't want to change that. Okay. If the received number is not equal to the ID of the robot, so this is why it's really important to make sure each robot has a unique ID number, then, and that your pick random number is set up correctly, because you always want to create a number that's in the range of all the robots you have. So if you have 3 robots, you only want to create a received number that's 1, 2, or 3, because if not, then you're basically not going to be able to, you're basically stuck, because you'll have a find a flaw in your program, and then you'll have to just shut them down and fix that issue. Because if you send a received number greater than the IDs of all your robots, like you send a 4, then basically nothing happens, and then all 4 MicroBits no longer have, none of them will have control of the skull. So, but if you send a 3, okay, this robot's 3. If you send a 2 or a 1, it'll drop to the else, and then it'll basically say Haskell is false, so it won't have control. So I know that was kind of a long-winded rambling, but let me check. I want to check something for you. So basically we're saying we want an if else. We're doing this isn't a logic. We're basically doing a logic comparison. We want the variable ID to go there. And then we want received number I think I have to come up with a better way to do that. So okay, so that's how that works. Okay, so let me show you that again. I just wanted to do that again to make sure that how I did that. But so when you're setting up this if statement right here, you grab comparison, plop it there, grab the ID one there, plop it right there. Hope you can see that. Then take the receive number, Put it right there. So yeah, let's do that. So basically what you do is once you get it inside the on ready received, you have to have it inside the on ready received, the if statement. You can grab this receive number and use it within inside the block. That's what I did wrong. See how you can assign it? If it's inside the block, you can assign it. But if it's outside the block, let's show that to you again. Because I didn't make myself clear. Because this if statement is not inside this on receive block, you can't use this variable. You can use the variable within here, within a block. So let's do that again. Because this if statement is within inside this on received block, you can use the receive number and assign it to this if statement. Put in the if statement. That makes sense because you just can't plop a receive number anywhere you want, because it's not, the program's not in the flow of the program. It's not going to understand what the receive number is until you receive a number. So there's no point of writing the code outside the receive number on ready receive if you don't if you're not receiving a number. So I know that kind of got a little complicated there. So let's flip over real quick to JavaScript. It's just kind of cool to just kind of work through this in your mind. Set it up, get it to work, test it, kind of go through the workflow because it's a little more complicated. So basically the first one here is basically the ready or received method. And basically what we're saying, when you receive information, in this we're looking for a number, not a string, we're looking for a number. We do this method call, and basically calling the function to receive number. We're passing the received number into the method and then evaluating the received number. If the received number is equal, is basically equal to the ID of the robot, then set Haskell to true. It means the MicroBit then has control of basically the icon for the program. Then show the skull icon on the front LED. Then if it's not equal to the ID of the robot, then the robot doesn't have control and it's basically false and you don't display the skull. So then on input, so this is another method call. On input, if you press the A button, you're basically saying we want to do something if the A button is pressed. And we're just basically saying if the Boolean, so the Haskell is true or false. So we're basically saying if it's true, send a random number, create a random number between 1 and the number of robots we have. This is 1, the beginning number, and the next value is how many robots in our group. And then we assign that to the send to number. And then if it is not equal, this is not equal to the ID of the robot, then basically Haskell is false. We don't have this control of the skull now. Show the ID of the robot, and then send through Bluetooth radio, send the number that we just generated, random number we just generated to other robots. This is basically setting the global variables. Let send to equal to 0. Let Haskell equal to false. ID is equal to 0. Let robots equal to 0. So this is basically just showing us our global variables, those 4 global variables we have. This is a comment. / is a comment. The compiler doesn't care. The computer doesn't care. The robots don't care with this / this is the comment. This is the number of robots in the group. I'm sorry, this is your group number, and then the robots is the number of players in the game or robots in the game. Robots is equal to 3. That's the number of robots in the game, and the ID of this robot. So make sure that you change this each time you upload. So each robot has a unique number. In this case, it's 3. For the other robots, it would be 1 and then 2. This basically says just display the ID number of the robot. Make sure each robot has a unique number. If the ID is equal to 1, that means it's the number 1 robot, and it has at the beginning of the game. So remember, this is on start. Then at the beginning of the game or the play or the beginning of the program, Haskell's true, means that number 1 has the skull to begin with, and the other ones do not. So then after we get this code all done, it's pretty hard to test it. As you can see, it displays the number. When there's more than 2 microbits, it gets kind of confused. The simulation doesn't really work very well. So that's why I ignored it. So now I've uploaded the code to all 3 robots. So let me stop sharing the screen so that we can show this program in action. I'm hoping this all makes sense. If not, please leave a comment, a question in the comments underneath the video, so maybe I can try to help you if you're having issues. So let's turn all 3 on. Now again, I'm using hope you can see those. That's 1, that's 2, that's 3. 1 is this joystick. So I'm using these DF robot stuff. You don't have to use these DF robot McQueens, these 2 McQueens and the joystick here. I'm only doing that to power the microbits to make this a lot easier, because each of the microbits has an A button on them. But you need to power the microbits, so you can actually get batteries that plug into the USB connector. But I don't have 3 of those, so I'm using my DF robot stuff to make my life easier. So however you want to power your microbits is fine. So let's do a quick test and see what happens. So if I press the A button of 2, 1, I keep pressing it, nothing happens. And the reason why nothing happens is because based on my code, this is a test of my code, number 2 does not have control of the skull, cannot transmit the skull to any of the other 2 robots. And it should be the same for 3. I'll press 3 A button here, and it will not transmit. I'm just constantly pressing it. It will not transmit to the other microbits. And if you remember, there's an A button right here on every microbit, and there's the B button. The cool thing is this joystick has an A button here and a B button here. So I'll show you what happens. So I'm going to press A because this one has control of the icon, of the scroll. Let's go. So let's press A. It took a second, but now you see the skull is now on the third robot. So the other two robots cannot now transmit because robot number 3 has control of the skull. So we press the A button on robot number 3. Number 1 gets it. Hope you can see that. 2 gets it. 1, 3, 2. Okay, so I pressed the A button for number 2, and as you see, nothing happened. And the reason why nothing happened, it's a slight flaw in my code. 2 basically randomly generated 2. That's why nothing happened. Let's do it again. It's funny, randomly generated 2 again. Let's try it again. So this time it generated 1. Okay, just generated 1 again. So 3 gets it. So if I press A, if I press the A button for 1 again, nothing should happen. Pressed it. Nothing happens because only robot 3 has control of the skull right now. Only robot 3 can transmit. Based on our code, only robot 3 can transmit to the other 2 robots. Hope this is making sense. Randomly generated 3 again. 3 again. 3 again. Keep randomly generating the same number over and over again. And this is a flaw in the code. There it goes. So that's the little flaw in the code. You can press A, and if it keeps randomly generating its own number, nothing happens. So I just generated 2, randomly generated 2, and 3. You do this forever, but see, the cool thing is that you can set this up so 1 through 255 robots get this command. So this is kind of a cool intro way to controlling multiple robots from the same controller. So you can basically set this controller up to control multiple robots. And basically what you do is you just toggle. Basically, you're kind of toggling from robot to robot. So you can have one robot do something and then the other robot takes control, or you can have this one control 2 robots, remote robots, and you just switch back and forth between the robots or which robots you want. I think it's kind of a cool demonstration of the Bluetooth capabilities of this little robot. And basically this gamepad is using Bluetooth. So this is basically a little robot control pad. So there's a keep, this controls movement, and you got different buttons and A and B. But basically it's using the Bluetooth of the MicroBit to transmit it back and forth between this controller and a robot. It's pretty cool. It's a pretty cool add-on if you're interested in doing some remote control, but we'll show that later on. So this is basically the program. It seems to be working the way I hoped it would work. That's the whole point of testing. You never know until you start testing whether something works right or not. Past it, and so on. Cool. There you go. I think that's a pretty good test. I hope that made sense. I know this is kind of long and drawn out, but I think if you play around with these radio control, Bluetooth control from MicroBit to MicroBit, this is a very powerful, I think, very cool thing that the MicroBit can do. Not only you can send numbers like we're sending now. We can send text, so I'll do one in the future sending text. But this gives you the ability to communicate back and forth and do all kinds of little cool things with this MicroBit. So very cool. So if you have any questions, suggestions, anything you want me to show in future videos, please leave a comment and underneath this video. I hope you found this informative and interesting and cool. I hope to see you in my next video. And thanks for watching. I hope to see you again. Bye.